the real core thing of what we do is we build autonomous boats and ships. From a technology standpoint, the technologies existed. We see Waymos and Teslas driving themselves. Most of airplanes are basically on autopilot, right? That technology is going to hit the maritime market. So we build unmanned boats and ships.
So basically, what SpaceX is to space, Saronic is to maritime. Is that?
That's a relevant analogy, yeah.
Good afternoon, everyone. My name is Hillel Ofek. I'm the VP of Communications at UATX, and I'm very pleased to be joined today by Vib Altekar. He is the Chief Technology Officer of Saronic Technologies right here in Austin, Texas. And Vib is actually one of the most important tech leaders in the entire world. And if I could, maybe by way of explaining why, I'll just say that right now on the side of the highway in Austin, there's a few warehouses where a bunch of bearded men and unbearded women are building boats. I'm not sure why they have to be bearded, but I feel like if you're building a boat, you have to have a beard. And they are building these boats and ships that in 5 years, if China decides to get into like a hot conflict with the United States, they'll probably think twice to do so. Or if the United States is in a hot military conflict with China, the United States will emerge victorious and will maintain our global supremacy and freedom. So Vib is in charge of all of the technical development in that company. And that's why I think he's one of the most important tech leaders in the entire world. So Vib, thank you very much for coming here today.
Thanks for having me.
So, and I'm reminded that there's an inverse relationship by how formally you dress and how consequential you are. So you're, somebody is really consequential when they're just wearing a t-shirt. So I wanted to ask you first, maybe this is like the first thing that people are thinking about right now. So a naval company in Texas, in a landlocked city, Austin, why? Why Austin?
Yeah, it's a great question. There's no water here, so it's pretty difficult to test maritime systems. I think there's probably three big buckets. I think the first one, first and foremost, is talent. Austin has a great network of talented folks in technology and finance, in law, but also has a good talent pool that comes out of the university systems. Two, it's close to historically industrial cities. So you have a large industrial talent base in San Antonio. You've got the oil and gas industry in Houston. So it's close to talent. The second big reason is where do you have space? Like where do you have like real estate to actually expand manufacturing? We brought kind of the automotive approach into kind of boat building. And so you kind of need long factory lines, you need production lines, you need the talent and capacity to keep those running week over week. And so from a real estate perspective, of course, Texas was a great place to start. And then the last part is just support from the state. So like local and state, Texas is very pro-military, and so you have a lot of veterans that live here, and so you have a lot of natural support from the kind of extended community.
I feel like one of the things that Saronic has in common with UATX is both organizations are explicitly patriotic. I believe so. Saronic, in its mission, says we are a united team that puts the security and defense of our country and its allies first. And this is kind of a new phenomenon. So a few years ago, it was really rare to see any company be so kind of out in the open in its patriotism. There was like Google had a project called Project Maven that was canceled because employees were protesting it. This just a few years ago, maybe like 2018 or something. So this is kind of a new phenomenon. So what changed over the years? Because you were, and maybe you could share a little bit about your background, because you've been very early. You were like an early engineer in Anduril, right? So you were kind of taking that risk very early on. So why did you do it, and how did that change over the years?
Yeah, I think the really wonderful thing about the United States and especially Silicon Valley over the last handful of decades is that, people have really built, the United States has really built these extremely global companies. And if they're an extremely global company, it's really difficult to get all of the incentives aligned to, one, first protect, America's interests, and then two, also be a global company. And so I think for some of the folks, it becomes this like internal challenge when you have these like globally distributed offices, but then, how do you have stances on very nuanced and deep political issues? It's a difficult problem organizationally. But for us, and I think, I was an early employee at Anduril as well, which is, building for national security and defense. I think the important thing was that, like, that's okay. Like, it's okay for people to think twice about the work that they do and really align with the mission. What we just also believed was that it's incredibly important for people to believe that building for America and building for the United States is a priority. It doesn't mean that everybody has to work towards that, but at least there's some group of people that are dedicated towards it, so we can really make an impact. I think that you're right. I think the Overton window really shifted. I think in 2018 it was kind of, a little, rough around the edges if you were to, work on national security. I think that Overton window's past us. I think it's totally different environment today. I think people are excited to build for the United States. They're excited to work in the national security kind of field. And there's a renaissance of building and bringing, back historically, jobs that weren't in the United States back home. And I think it's really exciting.
And we will be taking student questions soon. So if you have any, please keep them in mind, and we'll line up soon. So tell us a little bit about what Saronic actually does. So what are you building, and why is it so important?
Yeah. So, our mission is redefining maritime superiority. I think boats and ships are really interesting from a historical perspective. It's the first mechanism that humans used to move around. Like, we actually, as humans, we invented, rafts and boats before we invented the wheel. Now we've been on the water and in oceans for thousands of years. We've maybe been in airplanes since 1906. It's like 120 years. We've been in space for the last maybe 70 or 80. But the technology in airplanes and kind of LEO satellites and space has drastically outpaced everything in maritime. Maritime is still extremely legacy. Shipbuilding is a fairly laborious kind of old school process. Just a lot of the technology boom that we've seen in other industries just hasn't hit maritime yet. I didn't think the forcing function was there, so I think some of the work that we're doing in national security is really a forcing function to kind of reinvigorate the entire kind of shipbuilding ecosystem. But really, from our perspective, it's, how do we build and reinvigorate and redefine maritime superiority in a way that comes from a technology first standpoint. So the real core thing of what we do is we build autonomous boats and ships. From a technology standpoint, the technologies existed. We see Waymos and Teslas driving themselves. Most of airplanes are basically on autopilot, right? That technology is going to hit the maritime market. So we build unmanned boats and ships, 6 feet, 14 feet, 24 feet, and beyond. We actually earlier this year, acquired a shipyard down in Louisiana in Franklin, where we're building our 150-foot autonomous ship. And we're just going to keep going larger and larger to both tackle DoD problems as well as commercial problems.
So basically, what SpaceX is to space, Saronic is to maritime. Is that?
That's a relevant analogy. Yeah.
Yeah, it's interesting what you say about ships kind of being like boats being like one of the oldest human technologies. So we've just seen like massive, logarithmic innovation across so many areas, and then like ships, it's like a ship in America takes like the Navy takes like 10 years to build one ship and costs like $10 billion. Why is that? I mean, I think like during World War II, we were building like over 100,000 ships a year, right? So what happened?
Yeah, I think there's two separate problems here. I think the first one is, yes, we've lost that kind of bone and that skill set of what it takes to really, industrialize a sector. I think that for a long time, most of the economic movement in the United States was geared towards, Wall Street and Silicon Valley, and so we lost a little bit of that industrial base. I think from the Navy side, I think it's a little trickier because I think just the incentive structure with these extremely extremely important contracts is just different than the way we think about business in the commercial world. As an example, if you're an enterprise business, what companies usually do is they take some risk, they build a product, they bring that product into the market, and then they see if people like it. And based off of that, they can continue to grow and scale. If people don't like it, if they don't find what is called as product market fit, the business won't do so well, and maybe they'll shut down. When it comes to government contracts, it kind of works in the opposite way. It's oftentimes the government is taking the risk of investing funded research and development dollars, and then they're also taking the risk of procuring it on the other side. And so the incentive structure becomes difficult here because whoever is taking the risk is more incentivized to make sure that that program goes well. And so it's not that you lose all incentive, but it changes your risk calculus, and you stop taking those really risky technology bets. Where without those kind of things, like you don't see self-driving cars, right? And so you end up being in an industry that's a much slower moving, not incentivized to finish as quickly as possible, but rather is incentivized to be extremely slow, methodical, but sometimes take longer than expected.
And tell me if this is right, but one way of thinking about it is global power is a function of naval power historically. So whoever dominates the seas dominates the world. And when you look at naval power, it's basically a function of how many ships you have, right? Like during World War II, Germany had these fancy Mercedes ships, or they had the Mercedes of ships, and the United States had much crappier ships, but we just had way more, right? And so that made all the difference.
Absolutely. I think we outbuilt the Axis powers 4-1 during World War II. And yeah, that the volume really makes a big difference because at the end of the day, the way that conflict is moving, these large, exquisite, expensive, bespoke systems just end up being like really fancy targets. And so the real way of solving, the way that at least the conflict is moving forward is who can build at scale, who can build in volume, and then two, if they're unmanned, how good is your software? Are these things actually working in unison? If you're building a lot of them, are you making sure that they still work? They're still operationally relevant. Those are the two things that really make us stand apart.
And moving a little bit to your kind of personal biography. So you studied electrical engineering at UC Davis, and how would you describe kind of like your academic development and your hobbies and how they contributed to what you're doing today? So is there anything that, like looking back, you think was very formative in your career path?
Yeah, I think I was always interested in math and science. Like those were always my two favorite subjects in school. But I think there was variance of, I think science I always liked, but math, there was variance as a function of the teacher that I had. So if I liked the teacher, I really liked math. If I didn't like the teacher, I didn't like math that year. And I think it was very obvious to me in like middle school. By that time, I was like, oh, like my grades are just going to be a function of who the teacher is. And it was tricky because it kind of puts this like weird dissonance in your mind of, do I like the subject or do I like the way that it's being taught? Is it just, does it just does it fit with my calculus of the world? But those were always my two favorite subjects growing up. I ended up going to school, starting off studying chemical engineering. I thought I wanted to go into renewables and get involved in making a difference in maybe solar panel or photovoltaic technology. Ended up realizing that didn't want to do that. So I switched my major about 2 years into electrical to give me a little bit more flexibility. Maybe I could go back to energy one day, but maybe I could also go into software. Actually, I think one of the most formative things was actually getting introduced to Joe and the 8VC community, because I think it really opened my eyes beyond just the science and math. I think growing up as like a person who really likes science, like I always was ignoring things like history and literature because I thought science was my favorite subject. Why would I worry about those? But I think spending time with people who are well-read and who think about these things actually opened my eyes to so much more than just thinking about the technology through one vector. It made me think about how do you build for problems that actually matter, and problems that actually matter usually have some sort of macro or global scale. And so the smartest people that I've met usually aren't just good at one thing. They're usually have some skill that they're exceptional at, but they have a good framework about thinking about problems, and they apply that framework across philosophy, economics, government, software, AI, whatever that discipline might be. So that was really eye-opening, and I think that's one of the reasons why I kind of found interest in a niche where I really like the intersection of kind of history and economics, as well as kind of the technology and the technological implications. And then what I aspire my career to be like is to work the other way with how can you drive technology forward that like rewrites history of the future.
And when you have young talent coming your way, whether you're mentoring them or you're assessing them for a potential job at Saronic, what are you looking for?
Yeah, it's a great question, and I think it depends. It varies from role to role. I think a little bit, but I think the non-negotiables are I think integrity and effort. I think it's trust is one of those things where humans tend to be very welcoming with their trust up front, but once it's broken, it's extremely hard to rebuild. And so making sure you're hiring and working with people that have high integrity, I think is an important one for us. The other one is I think there's some element of like base level of skill set and understanding of the world that's important. I think there's famous quotes in basketball like you can't coach height and things like that. But I think the person that just works, usually it's the person who just works much harder that usually ends up being that much more valuable of an employee or colleague. And I think a lot of the other pieces can be learned and skills can be honed, but really difficult to teach motivation that doesn't come from within. If somebody's not motivated to do something, you're probably not going to get that much out of them.
Yeah, it makes sense. And it reminds me, I got a top secret clearance when I had a government job. And during the assessment, what they would say is if they find out that you lied, that kills you. Like any kind of chance that you don't have integrity kills you because that's like the one thing that you can't really change in people. Like people who have integrity just have it. And so that seems like very important, right? So and the in terms of your background and everything, have you like kind of developed side projects or things that you kind of did outside of the academy that you feel kind of contributed to your career development? Do you tell young people like, oh, you should develop these hobbies in order to kind of advance your career?
I think naturally curious people just end up getting excited by the most random side quests. And so I think as over the years, I don't think I have a specific hobby that I can recommend or anything like that. But I think I have friends who spend their weekends going from contributing to open source projects on GitHub to writing in their free time, like a screenplay, and kind of expressing the creative side of their mind, to people that go geocaching. I don't know if anybody knows what that is, but it's like somebody on the internet drops some location of like a box and then you go find it. So just the most random and obscure kind of hobbies. I think the one thing that's like kind of synergistic across all of them is that it's driven by curiosity, not driven by, some framework of I should do this or I have to do this or people will judge me if I don't do this. It's driven purely by curiosity. And I think those things end up turning out pretty well.
So many of the students who are here today, they'll be graduating in the 2030s, essentially. The AI economy is going to be very different maybe than what it is today. What advice do you have to be prepared for that world?
Oh man. I think it's very rare to be present during a time where there's a fundamental piece of either technology or infrastructure that's growing at this rate, right? I think we've all been living through, the follow through from Moore's law. Moore's law was a law made by one of the founders of Intel who said that compute would get twice as good every single year, and that's been relatively held true over the last 35, 40 years or so. We sent somebody to the moon with more. There's more compute in my Aura ring than the spacecraft that went to the moon, and the compute's just been getting better over twice as good year over year. that has been a huge paradigm shift. I think AI wave kind of mimics the internet wave as well in that sense, where there's just never been a time where some piece of technology has grown this fast and become this capable. Even if ChatGPT is doesn't meet your requirements and falls short by 20%, the reality is that 6 months later it's going to be 10 times better. And so the problem of 6 months ago just doesn't exist. And so I think when we're living in a world like that where something's growing that fast, it's really hard to predict what other things will change. Humans are generally bad at kind of grokking exponential growth. And so I think that not being AI, my personal 2 cents is that not being AI native today is like, in being probably in 2000 saying, oh, the internet's just a fad. Or it's being like in 1890 being like light bulbs are a fad. Like I'm going to stick to candles. I think that's probably the same analogy that I would use for folks today thinking about AI, where you probably want to be in a world or kind of sit with the mentality that, hey, this is a piece of technology that's growing so quickly, it's unprecedented. And in a world in which it's likely true that these systems will continue to expand and get better, you want to be, one, AI native, but two, also find yourself in a place where the tools only augment your abilities. You're not completely reliant on the tool for everything, right? And that's the same way we treated the internet, the same way we treated light bulbs in 1890. And I think with most of the technology waves, like this is the way that we should probably look at them.
If you have a question for Vib, please line up here and feel free. Anything about career, AI, what he does, how he got there, please go ahead. And maybe while we're waiting, I know that every time Saronic comes up in conversation, or whether it's like on CNBC or something, the first thing that people say a lot is, wow, like you guys grew so fast. $4 billion valuation, raised $850 million in 2022. Yeah, so pretty incredible pace. What is it about the business and technical culture of the company that you think contributed to that?
Well, I'd start off by saying I have an incredible team of co-founders. So Doug Lambert, who's our COO, has been in maritime robotics for the last 15 years. He was at Liquid Robotics that sold to Boeing. Rob Lehman, who's our chief commercial officer, spent 20 years working in shipbuilding companies as well as working with folks close to Congress. And then Dino Mavroukas, who's our CEO, former SEAL team operator, worked in private equity for 5 years and is now the CEO. So one, I have an incredible team of people that I get to work with. And then two, I think, we're standing on the shoulders of giants, right? Like you have, phenomenal companies like SpaceX, Palantir, Anduril, that carved a lot of the path so that other companies can come and follow and continue to innovate. And so I think, even from a technology standpoint, we get to, build off of what people have built before, which is really exciting. It allows us to move quickly. It allows us to have a lot of focus. And in a world full of distractions and in a market full of distractions, I think focus is honestly the biggest luxury we have. And so that helps. We've got incredible people and talent across every department, from testing to finance to software to government relations. I think those are the really big unlocks.
All right, introduce yourself and ask away.
Hi, I'm Eliana. I'm an incoming student, class of 2029. My question for you is, for those of us who don't know as much about maritime defense technology, what does the competition look like? For example, like in China, or just for, I guess, any country. What are we competing with right now, and how fast are they moving?
That's a great question. I think I'll say one thing, which is, when it came to drone technology, like unmanned aerial vehicle technology, the market started really, one post G, like during GWAT, but also 2006, the FAA changed regulation so that people could actually, fly their drone over line of sight radio. From 2006 until now, most large companies like universities, there's open source, tools out there. Everybody can basically build a drone in their garage today. All the tools exist, the parts exist, you can just buy them. It's a weekend project. We see the same thing happening now with Maritime, but it's just going to take a little bit longer. And so I expect that over the long period of time, this will end up looking very similar to drone technology, where it'll get commoditized, anybody can do it in their house, et cetera. But until that time, there's just a lot of innovation that needs to happen. And so from our perspective, what that looks like is, can you understand perception on the water? Can you get your robot to understand the world? Compute has gotten better, so we can run fancier AI models at the edge. And then the last piece is that one thing that people always forget to think about is that in the middle of the ocean, there's no internet. And it's really difficult to get internet. So how do you actually talk to your system? So as we're innovating on that front, the competitive landscape tracks kind of in a similar way, either because of the market forces or due to geopolitical reasons. Geopolitical reasons I would not be able to share on this stage anyway, because I'll probably be sensitive. But from a market standpoint, you can track that, like, hey, people are in the world of what did we build for drones, and then how do we get that into the water? What did we build for self-driving cars? How do we get that into the water, and kind of work their way from there?
Thank you.
And I think Chinese production comprises like half of the world's shipbuilding, right? So if you add up all the shipbuilding around the world, like it only reaches parity with China, right? Which is kind of a scary concept.
I have a question in a similar vein in regards to military technology. How do you see maritime technology kind of keeping up with the modern military? You see, notably with the Air Force and with planes, you see competition in air warfare, mostly regarding speed. And we have like a large part of our military technology is concentrated in things that operate either too high or too fast to really effectively attack with conventional weaponry, which is the way that most of our maritime defense works. Do you see us shifting more towards, larger ballistic responses? Do you see more innovation coming from the railgun industry? How do we make our boats keep up with our planes so that they're still, useful to have in military responses?
Yeah, that's a great question. And I think the CNO in the Navy actually pushed out like an initiative to get, the fleet to go from being manned the way it is today to I think 60% unmanned, 40% manned over the next 10 years. So I think there's two vectors here. There's one which is us keeping parity with the aerial systems is not necessarily just a function of speed. It's also a function of safety and the ability to stay clandestine and the ability to network things together. So there's a lot of things that ships do and navies do that necessarily aerial systems don't necessarily have the ability to. Right. As an example, if you're an aircraft, it just burns you burn power just staying in the air. Right. As a boat, you burn no power just loitering. So there's a lot of advantages that you can get by being at the surface of the water. The other thing is that the way that we solve these problems is through volume. Right now, there's genuinely a shipbuilding crisis in the country. Right, as you just mentioned, we have our shipbuilding capacity is extremely low compared to not just China, but any of the large premier shipbuilders in the world, South Korea, India, like all of these places. And so the other way that we solve that is just through volume. That's one of the things that the UAV world and the drone world has got right. There's a lot of folks that can build a lot of drones very quickly. And we just need to bring that same level of effort and reward and outcome to the maritime and shipbuilding world.
And we're retiring more ships than we're building, right?
That's true. Yeah, in the U.S. Navy today, there's a congressional mandate, I think, for about 355 ships. Our current ship count is lower than that, and we're just not building fast enough to keep up with the demand and supply that we need.
Thank you.
Since you mentioned AI becoming a big part of the future technological landscape, do you think classes like cybersecurity should be taught to high school students?
That's a great question. Personal opinion, I do think that internet hygiene and technology hygiene is something that we should take very seriously. Maybe not just cybersecurity, but just generally as somebody growing up, in the year 2025, if you're in anywhere from elementary school to high school to university, if you don't understand how the system works and how it affects you, you might be susceptible to a lot of bad things, right? Especially kind of understanding how do these recommendation algorithms work, when you put data on the internet, it stays there permanently. And like getting understanding of like how to interface with the technology and just general cybersecurity hygiene of just like don't connect to all of the random Wi-Fi ports that you see. Use secure passwords. Like all from that all the way up to hey, how do I actually handle myself and communicate over the internet as well? I think those things would be incredibly valuable to learn as early as possible, especially today, where basically there's more phones than humans, right? So I think it would be super important.
Hi, so I'm curious, this is in regards to UATX. What do you think makes UATX so different from other universities in regard to the experimentation and growth in AI? And how do you think it's going to help in that?
Well, I think one of the biggest advantages is the network, right? You have access to folks from the VC community, like for folks like Joe, folks like the entrepreneur and technology scene here in Austin. And I think, if I look back at like, just education as a whole, right? You are, reading a textbook or like reading some PDFs and getting an understanding of what's going on as a snapshot of time when that book was written. The challenge with AI and the challenge with technology is that it's moving so quickly that even if you wrote a book, by the time the book was published, the technology is probably out of date. And so, having close access to a network that is actually at the bleeding edge, there's no remedy for that, right? That's your best bet at being as close to these things as possible. Yeah. Anything you want to add to that?
Yeah, and I think that there's like a lot of schools that have amazing networks. Stanford, a great network, but we got Vib here because we like sent him an email and we just like sent him like we have people like Vib like on the tips of our fingers, like everybody in our board, our staff. I talk regularly on like a almost daily basis with the person who's like the reason why Saronic was founded. Because they introduced the CEO to 8VC, so we just know these people, and all it takes is like an email to one of us to connect you directly with people who, I don't know how many LinkedIn requests you get every day, but it's probably like hundreds, right? So you don't need to do like a shady LinkedIn request. We'll just make it happen for you. So I think that's really important.
All right, thank you.
Do you believe that artificial intelligence will ever achieve sentience? And what does that mean for the future of warfare?
I think to answer the first question, is AI ever going to be sentient? I think we probably as humans need to better define what consciousness and sentience means. I think there's a lot of open debate, I think, in the research community, in the software community, as well as on the policy and kind of economic, in the economic world, where how do we actually define it first? How do we know, and how do we know that once we've defined it, how do we know we've achieved it? Was that the right metric? A good example is, one of the previous metrics for if a software was sentient was a Turing test made by Alan Turing. And the test there was that if the software could trick you to thinking it was a human, or that you would think it's a human, that you passed the Turing test. Now, ChatGPT has blown past that in every way, shape, or form, right? But we still don't necessarily think about it as sentient today. So I think the first question is, how do we define it? I think that's open for interpretation. Do I think we'll get there in terms of, some sort of, variant of sentient? I think so. I think generally speaking, the technology is growing fast. I think, it'll probably end up doing wonders in the next handful of years, and we'll all be blown away by where the technology stack sits. I think the implication from a war and kind of defense and national security perspective are completely massive. I think it's unequivocally true that something that is capable of decision making at that scale, there needs to be some guardrails, but there also needs to be very thoughtful determination of how these things get used and who uses them. I think a lot of folks in government are working towards this now, with different kind of policy approaches and things like that. The challenge is that technology outpaces policy. And so, I think it's important for everybody to stay dynamic during this time as everything's moving so quickly, and then, be resilient and figure out what the general strategy moving forward should be. And I think it's important that, the United States leads on that front.
Do you think that adding a machine in between the people making decisions and the actual battlefield or naval or a specific naval conflict, do you think that would make war more impersonal and therefore more devastating?
It's a great question. I think I think the thing that I'll say here is that it's important that we give our warfighters and men and women in combat access to technology that saves their lives and make sure that they're able to make the best decisions they can. I think that's important. I wouldn't want their computer to be flaky because that could put people's lives at risk. It could put the decision making quality at risk. So I think it's important to make sure that, just like they trust, the phone in their pocket, they should also trust the technology of the systems that they work with. I think that leads to more responsible outcomes, as well as protects more lives.
Thank you.
I'm James. I was wondering it's a simple question, but I was wondering what some of the greater problems that you faced are, how you overcame them, and what you learned from them.
Oh man, it feels like there's one every week. Let's see. I think the fun part about entrepreneurship and the fun part about building companies is that the problem changes. It's kind of it's like an amorphous. There's like a amorphous blob problem every week, and it just changes its shape depending on what's going on currently. Sometimes it's technology risk. Hey, we're not able to move fast enough on the production line, or the software component doesn't work, or the hardware is failing, or whatever. To hey, we're running out of parking space, and we've hired a bunch of people, and we're running out of parking. We need to go fix that because otherwise people are parking like 30 minutes away, and this is just not tenable. To hey, how do we navigate a challenging customer ecosystem where your requirements process, or the purchasing process is extremely slow and asynchronous. So I think the problems change from week over week. I think hard to pick one that was like the hardest, but I think the general thing that I take away from it most of the time is, I think one is maybe a little sad. I try to make sure that like I'm always within. I don't count the wins too high, and I don't count the losses too low. It's important for me to like just keep moving forward. Like, don't think that every single mistake you make is fatal, but then also don't get too complacent with every win. You just keep trudging forward, and then taking that framework across technology problems to parking lot challenges. It seems to scale just fine.
Hi, I'm John Susong, and you mentioned earlier that you don't think integrity is something that can be taught, and I was wondering why.
I think you mentioned that.
Yeah, I might have mentioned it. I'm not sure I have a good answer to it, but I mean, I was just saying that I didn't necessarily believe it, but that's kind of what the people who kind of assess character for the U.S. government, when they're trying to decide if you're qualified for a security clearance, they usually take lies and dishonesty as just like a red flag that can't be overcome. So it's worse than hacking. It's worse than stealing. You can still get a security clearance if you steal, if you do bad things. But if you lie to them, that's kind of a no-go for them. So that's what they think, at least. But it's a good question for them. Yeah.
Yeah, I guess the way that I would explain it is like, people make mistakes. And I think the people with that we're looking to hire are okay with admitting that hey, I made a mistake, and I'm okay with it. I'm just making that clear and handling that in a low ego way. And then B, like as you mentioned, like if you have a tendency to lie or kind of lie, cheat, and steal in kind of that form, just nobody's going to trust the quality of the work, or nobody's going to trust you as a person. So it's important for us to filter those things out first.
I've heard that the US Navy puts a lot of research into energy engineering and technology, and that seems doubly important to Saronic because you have to power AI as well as the vessels themselves. What are Saronic's plans for energy scaling into the future?
It's a great question. We don't specifically invest on the energy front on the technology side today. It might be something that we do over the course of the next handful of years. Right now, our big focus from a technology standpoint is on the autonomy and software. And I think the incremental advances that we'll get by better energy systems will then end up compounding as the software gets better and better. Yeah, you're absolutely right. So both battery and diesel technology is like usually the standards for what the work that we do today, and that'll continue to evolve.
Are these Saronic vessels, are they diesel, electric, both, or what's it?
We have both electric and diesel systems.
Hi, I'm Brett, and I was just taking some notes on my phone over there, and I was just kind of had a more practical question. You've mentioned that our other medias of warfare have experienced booms, whether it's space or air, that the maritime really hasn't. I'm just curious kind of how the recent tariffs have really affected y'all's development.
Yeah, it's a good question. I think naturally, like all of our, the tier one suppliers that we work with, and other great companies that build some parts, bespoke systems, or whatever that we use as part of our production line. These problems are interesting because they cascade all the way down, right? And so it's not just the cost of a inertial unit that goes up, but it's like all of the downstream components as well that results in a challenge. So from our perspective, it was just getting a good understanding from our tier one and tier two suppliers, like what the potential price differentials would be, and how do we combat those things, and how do we make sure that we're in a spot ready to handle those. But other than that, I think it was one of those things where we're just waiting to see how it really plays out.
So I had a question about how in the field of autonomous warfare, by creating a bunch of autonomous vehicles, boats, you're effectively replacing people on the battlefield. And this is great for the preservation of life, but it also means that there is no risk to life when one engages in maritime warfare. So by creating these autonomous vehicles, you're basically making it easier for people to go to war without risk of loss of human life. So how do you reconcile that you are trying to build something clearly not for the purpose of killing people, but by creating these technologies that save lives, you're also making war easier?
It's a thoughtful question, and the thing that I'll say is the reason why we want to build and invest and have the capacity at scale is so that the conflict doesn't start in the first place. Right. Historically, countries with larger navies have been the ones to deter conflict from even starting. And that's really the place where we want to come from, which is, hey, we've got the best software, the best scale, the best that we can produce at the highest volumes. That should result in and strike fear into people who think that, hey, there's even a chance of having conflict. Right. One of my former colleagues always used to say, like, people only get into conflict if both sides think they're going to win. Really, the way that we want to go is you have the capacity and the ability to execute that's so great that you deter conflict from even starting.
Hi, thank you for being here today. I just wanted to know if you could provide more detail into the tactical advantages that your ships and your technology provides.
I wouldn't be able to share too much, but what I can share is that a lot of the technology that people used to take for granted in the air. So, a drone that like flies from like point A to point B, we take some pictures, can stream video, kind of these things that we've taken for granted with drones for a while. A lot of that technology is still a little nascent on the maritime side. And so there's actually making sure you have extremely robust comms networks when you have salt water hitting your antennas, and when salt water hits your antennas, you have attenuation, or how do you still communicate when you have extremely high latency and kind of low bandwidth networks in the ocean. All of these different technology challenges that end up translating to tactical advantage or disadvantages, right? And so it's right now we're in this interesting place where the technology is still nascent, and you're working with folks that are using these systems consistently to get an understanding of like what the upper limit is going to be.
First of all, thank you so much for being here. I'm just curious, how do you plan on balancing the input of AI versus a human input for your naval ships?
So the way that we think about, I think we'll have to dig a lot deeper into like the way that we define AI as well. I think as it starts to branch off in a bunch of different directions, there's some AI that translates to like vision software on the boats or on robotic systems that allows it to understand the world around it with cameras and lidars and radars and things like that. There's another version of AI which is like the ChatGPTs and LLMs of the world that are more like chatbots and text agents. And then you have like kind of AI supercomputer systems that like on the HPC side that are kind of doing their own thing. So for us, the way that we think about it is that we don't want there's not a world in which AI is making a decision that a human is responsible for. The responsibility of the software and the systems behind it is to just augment the amount of information that an operator has so that they can make the best decision. And so really from our side, it's not like AI is going and, making decisions and hitting endpoints on its own. It's really just augmenting the human's ability to sit there and operate the vessels.
How did you get a Department of Defense contract? Was it just you go to the Department of Defense with your idea, or did they first publish the contract looking for companies to solve the problem?
Great question. Selling to the government is a different, go-to-market motion than either selling to your friends or selling to companies. It's actually one of the parts that I think is most underappreciated about how these defense technology businesses actually work and operate. Like it's just a very challenging go-to-market because your customers are in DC and not necessarily the people that are going to be using the product at the end of the day, right? And so in other markets, right, if I was to sell you a cell phone or if I sell you a TV, you're buying the product and you're also the final user of that product. In the government world, or in the DoD world, it doesn't necessarily work that way, right? The customer that you're selling to is not the person who's going to be using the system that you just sold them. And so there's a lot of nuance when it comes to actually like landing and securing government contracts and making good relationships there. But you hit on one of the approaches, which is sometimes the government will drop like an RFI or an RFP, which is basically a public solicitation of, hey, this is what we're looking for, and there's a website for it, and people can go and apply and submit their solutions. There's organizations like DIU, Defense Innovation Unit, that does this for commercial solutions. And so it's basically applying, almost like applying online. And then there's like a down selection process and et cetera. So, but that's just one vector of how to go about doing it.
So Saronic, did you go by that method, or did you approach the Department of Defense directly with your solution to?
There's a variety of ways that we work with the government, but this is one of the ways. Yeah.
Okay. Thank you.
Such great questions, right?